Hello students, welcome back. We went through a couple of quadratic models. One example was business model, and that was rather straightforward. All I had to do was R equals XP or PX and simplify. We had quadratic expression, and then we can work it out through the intercept form and if necessary the vertex form too, and answer all these questions. Intercept form was quite useful, getting the graph and then doing further computation, so I used it here. But if you prefer to use the general form, unlikely, or vertex form, even less likely, go ahead and use those. This time a geometry problem. In this case, getting the area was a little bit trickier, but once you get it, you get the general form, and then factoring out, we get the intercept form. Intercept form is quite useful in predicting the shape of the graph. X-intercept here, 0, and another one, 2000, and thus the maximum at the average, 1000, like that. And then plug in x equals 1000, you can get the area like that. We went through that too. So in a broad sense, both examples were utilizing the intercept form and getting the h value as the average of those intercepts. Okay, let's consider the third example, and this is going to be some advanced geometry. Okay, a Norman window has the shape of rectangle surmounted by semicircle of a diameter equal to width of the rectangle, like this picture. If the perimeter of the window is 20 feet, what dimension will admit the most light? That is maximum area. So 20 feet width, and then this vertical height, left and right, and then the half circumference. That must add up to 20 feet. From there, you have to get area, and that'll turn out to be a quadratic model. Well, I'm not going to be surprised that this is a quadratic model because area is two-dimensional quantity. So width times height, basically. So it's two-dimensional, so second power. And then perimeter is one-dimensional quantity, so add up to just feet. So area is square feet. So they do make sense. But other than that, it's a little bit difficult to set. So here, let me give you a simplified diagram, because this picture looks nice, but it gives you too much information. Okay, here we go. Here's a simplified diagram. We have green region here, x, x, those are vertical. And then we have semicircle up here. And then in order to get the circumference to pi r, or actually half of circumference, pi r, we get the radius r like this. And then down here should be diameter, so 2r. So what do you get? So the perimeter, this has to be, let's see, x plus another x, down here 2r, and then pi r. That's going to be the perimeter. Pi r is over here, half of 2 pi r. Remember, circumference is 2 pi r, but half of that. And x, x, and then 2r. That's the perimeter, and that's add up to 20 feet. Okay, from here, let's see. Let's simplify a little bit further. X, x, so let's rewrite it as 2x. And then let's see, 2r pi r. Okay, let's write like this. 2 plus pi. Too complicated? I don't know. On second thought, let's go back. 2r plus pi r. That adds up to 20. Okay, what is the area? Area of this green rectangle. So 2r times x. And then area of this blue semicircle. Whole circle has area pi r squared, but half circle, so 1/2. So you have to model this area, which is quadratic. But we have a problem. We have two variables, x and r. Is there any way to reduce it into a function of single variable? Yeah, you can do that. You can solve for x from here and plug it in. Okay, how do you do this? 2x equals to 20 minus 2r minus pi r. Okay, divide everything by 2. X is 10 minus r minus 1/2 pi r. Got it? And that goes right here. And this one here, x, is like that. And then if you simplify, you're going to get a quadratic expression. We'll see. Is 2r times 10, so that's 20r. Are you with me here? 2r times r, so 2r squared. All right? 2r times pi r, so pi r squared, and then 1/2 pi r squared was there before. Okay? Is there any kind of simplification? Looks like it. Negative pi r squared, positive half of pi r squared. So A is 20r minus 2r squared minus 1/2 pi r squared. Okay? All right. One more. A is negative of 2 plus 1/2 pi r squared plus 20r. Is this necessary? I don't know. Is this necessary? Well, yeah, I have it here. So this is a value which is negative. So we have concave down, we'll have maximum. And then this is B value, C value is 0. But I don't know whether this is going to be really necessary. Let's work this one out. Factor r out, what's left will be 20 minus 2r minus 1/2 pi r. So the intercept form will be r equal to 0 or this thing equals to 0. No, this is even harder. Let's not work this out. Let's come back to here. Getting these two together, we get negative of 2 plus 1/2 pi r squared. So that's a value, and that's b value. So h is negative b over 2a, so that's negative of b, which is 20, and then divided by 2, and then negative of 2 plus 1/2 pi over 2. Oh my, it's just so negative, positive. So I'm going to lose this. I should have punched in the calculator and get decimal expressions. Well, precise value for h will turn out to be 20 over 4 plus pi, but if you use pi equals to about 3.14, about 2.8005, so yeah, I think it is safe to just take one decimal digit, and that is my h value, and then plug that into, well, let's see, r value either here or here, any a value or here, and then run your calculator. Then you're supposed to get the k value. So from here, I'm plugging in 2.8, and then I'm plugging in 2.8, and let it run. As a matter of fact, to be a little bit more precise, I would like to have just a little bit more decimal digits. 28.005. Okay, all right. So about 28. Okay, there you go. And the maximum will take place when this radius r value is 2.8. So the diameter is twice of that, so 5.6. And that in that case, x value is, after doing this computation, which I didn't do yet, but that's doable. But in any case, in that case, the area will turn out to be 28 square feet. Holy cow. Here we have this, and then about 2.8. Do we have maximum around 2.8? Yeah, it looks like it. And then around 2.8 we have maximum, and then area 228. And by the way, R max and X max turned out to be the same. That was a bit of a surprise. Okay, if you do this computation, 20 over 4 plus pi, so the X value and R value will turn out to be the same. So this picture is not really a good picture. In the maximal case, this window has to be a lot thinner, a lot taller. Anyway, that's the conclusion. Okay, all right.